Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing single phase full wave controller with inductive load. And here, in AC voltage controller with inductive loads, we'll be seeing both continuous current mode of operation as well as discontinuous current mode of operation. And here, this is single phase full wave controller with inductive load. And for instance, here I have considered discontinuous current mode of operation. That is, we can decide discontinuous as well as continuous current mode of operation based on the value of the inductor. The value of the inductor which we choose, it depends upon. If we choose the very less value of the inductor, in that case, it facilitates only discontinuous current mode of operation. And if at all, if we are making use of very large value of inductor, in that case, it provides continuous current mode of operation through the load. And here, during the positive half cycle of the supply voltage, during which the polarities will be like this, positive, negative, and when T1 is forward biased, we will provide triggering pulse for the thyristor 1. And here, thyristor 1 starts conducting current through the load right from alpha, and it becomes maximum at this instant called pi. The current through the load is maximum, and the moment it reaches pi, the negative half cycle has been appeared. But the thyristor T1, it will not get turned off. The reason is because of the inductive load. And here, when the thyristor 1 is conducting current through the load, this is the direction of current flow. The moment when the thyristor is conducting during the positive half cycle till pi, inductor stored certain amount of energy in it, and according to Lenz's law, it tries to maintain the current flow in the same direction. So what? It changes the polarity to negative and positive. And because of this polarity, T1 is still maintained in conduction even during the negative half cycle of the supply voltage. So, the moment negative half cycle appeared, even then the thyristor T1 will not get turned off. And this particular thyristor will conduct as long as energy stored in the inductor is still present. The moment the energy stored in the inductor is 0, at that instant, the current through load will also become 0 at this instant called beta. So here, our thyristor 1 started conducting from alpha to beta. And the moment it reaches beta, whatever the energy stored in the inductor is completely exhausted and it is 0. So what? The current through the load is 0. And again, during the negative half cycle, because of the polarities negative and positive, thyristor T2 will be forward bias. And the instant 1, we provide triggering pulse. That is, at pi plus alpha, we provided the triggering pulse IGT2 such that thyristor 2 has been triggered during the negative half cycle of the supply voltage. So what? T2 started conducting current through the load in the reverse direction to that of the first case. So that is how we are getting the output current negative. And it is becoming maximum, and as usual, because of the presence of the inductor, T2 is still maintained in conduction, and the moment the energy stored in the inductor is completely 0, at that instant T2 gets turned off, and here the output current remains 0 from this period to this period. That is again the instant when we provide the triggering pulse. Till that instant, the output current remains 0. It is because we are using the less value of the inductor, and thereby inductor is providing the discontinuous current mode of operation. And the cycle repeats. This is it during the positive half cycle, and polarities will be positive, negative, due to which T1 will be forward bias, and T1 starts conducting current through the load and it becomes maximum, and because of the inductor, current is still flowing even during the negative half cycle of the supply voltage. Once it is exhausted, the supply voltage across the load will be 0. So this is what happening. And here if you see the same supply current is what flowing through the load. So that is the reason here I naught is equal to Is, same path. So I naught will be equal, output current will be equal to that of the supply current. And then coming to the output voltage for this particular circuit, if you see, whatever the supply voltage which we are feeding will be applied across the load as long as thyristor is turned on. As long as thyristor is conducting, whatever the supply voltage which we are feeding will be appeared across the load. So the moment alpha, when during the positive half cycle, since thyristor 1 is forward bias, the instant at alpha, when we provide the triggering pulse for the thyristor 1, only then it starts conducting from alpha, and it conducts till pi. And the moment it reaches pi, whatever the energy stored in the inductor is still present, and the polarities across the inductor is still maintaining T1 in conduction. That is the only reason this particular thyristor is still on. So what supply voltage will be appeared across the load. And here output voltage waveform will be following the supply voltage waveform. And once the energy stored in the inductor is 0 at beta, at that instant supply output voltage will also become 0. So that is how we are getting this wave shape. This pi, and this instant, the moment when output voltage is becoming 0, we call it as beta. And this output voltage is still remain 0 until we provide the triggering pulse at the next instant, that is during the negative half cycle, at this instant called pi plus alpha. Again we are providing the triggering pulse for the thyristor 2. So what thyristor 2 started conduction from pi plus alpha to 2 pi, and it is conducting even beyond 2 pi. That is because of the presence of the energy stored in the inductor, which is still maintaining T2 in conduction. And that is how the output voltage waveform is just following the supply voltage waveform. And that is how we are getting negative spike here. And this negative spike ends the moment when the energy stored in the inductor is completely exhausted. So it is becoming 0 at this instant called beta again, and it remains 0. And the cycle repeats. And here output voltage, here it is due to T1, here it is due to T2. And again, because of the positive half cycle, T1 turns on and the cycle repeats. This is the output voltage. And coming to the voltage across the thyristor. See, voltage across the thyristor, as long as thyristor is turned off, whatever the voltage will be appeared across the device. So that is nothing but voltage across the thyristor. When the thyristor is on, the on-state voltage of the thyristor will be very less. It will be equal to the on-state voltage drop, which is almost 0. So that is the reason we consider the voltage across the thyristor during its turn on as 0, and it is appeared across the device during the turn off period. So here, as long as thyristor is off, that is from this instant to this instant, here voltage across the thyristor will be appeared across the device. And this is nothing but the voltage across the thyristor 1. As long as it is off, the voltage across the device will be appeared. And once the device is turned on, see here at this instant called alpha, our thyristor 1 is triggered. So the voltage across the thyristor is considered almost 0, because the voltage across the device, on-state voltage across the device will be very less, will be almost equal to on-state voltage drop, which is almost considered as 0. And again it is appeared at this instant called beta, because thyristor 1 is getting turned off at this instant called beta, and it is remained off till next instant called pi plus alpha. So that is the reason from beta to pi plus alpha, voltage across the thyristor 1 is appeared. And coming to the current across the thyristor 1. Current across the thyristor 1, as long as thyristor is conducting current through the load, we will get the current through the thyristor waveform. See, this is the current across the thyristor 1, and it is conducting right from the instant called alpha, and it is becoming maximum at this instant called pi. And the moment it reaches pi, negative half cycle has been appeared, but because of the polarities across the inductor, T1 is still maintained in conduction, and that is how it is conducting beyond pi till beta. And again, thyristor 1 is conducted during the positive half cycle. And these are the individual circuit diagrams. That is, when thyristor 1 is conducting, this is the current flow through the load. And if you see, during the negative half cycle, because of the polarities, T2 is forward bias. The moment when we provide triggering pulse, T2 will be conducting current through the load in the reverse direction to that of the first case. That is how we are getting AC output using AC voltage controller. And that was the waveform for discontinuous current mode of operation. And let us derive V0 RMS expression for single phase full controller, full AC voltage controller with RL load. So here for V0 RMS, the time period is, see, every similar cycle is repeating for pi. So here time period is pi and the limits are, it is actually conducting from alpha to beta. And this is V0 square of omega t d omega t, where whole to the power of 1 by 2. 1 by pi alpha to beta, where V0 is Vm square sine square omega t d omega t, and here Vm square constant, bringing it out, Vm square by pi. And in order to integrate sine square, I am writing this in terms of 1 minus cos 2 omega t by 2, integration from alpha to beta. And here now I am bringing this denominator out, that is Vm square by 2 pi, and integration of 1 is omega t within the limits alpha to beta, minus integration of cos 2 omega t is sin 2 omega t by 2 within the limits alpha to beta. And if we substitute the limits, we get Vm square by 2 pi beta minus alpha minus sin 2 beta by 2, minus of minus plus sin 2 alpha by 2 whole to the power of 1 by 2. I am applying whole to the power of 1 by 2. So the equation transforms into Vm. I am taking this 2 pi inside. We get beta minus alpha minus sin 2 beta by 2 plus sin 2 alpha by 2 whole by 2 pi. And this is our V0 RMS expression for full controller, AC voltage controller with RL load. And this is single phase full wave controller with inductive load. And let us observe the waveforms for continuous current mode of operation. And as I already told you, this discontinuous and continuous current mode of operation, it majorly depends upon the value of the inductor which we are actually choosing. If we are choosing the very large value of the inductor, in that case, it facilitates continuous current mode of operation. And here, during the positive half cycle, polarities will be positive, negative. And because of these polarities, T1 will be forward bias, and the moment when we provide the gate triggering pulse, that is IGT1, at that instant, thyristor 1 will be triggered, and thyristor 1, this is the load current which I am actually indicating. Load current started flowing through the load. When T1 is triggered, it starts conducting current through the load in this direction, that is downwards direction. Show output current through the load. This is because of thyristor 1 is conducting, and the moment it reaches pi, actually thyristor 1 need to get turned off, but it is not getting turned off. It is because of the value of the inductor. Inductor stores certain amount of energy from instant alpha to pi, and the polarities will be positive, negative. The moment it reaches pi, it reverses its polarities according to Lenz's law. That is, in order to maintain the current flow through the T1 in the same direction, the polarities across the inductor will be negative and positive. And because of this positive polarity, T1 is still maintained in conduction even during the negative half cycle of the supply voltage. So that is the only reason T1 is still conducting beyond pi even during the negative half cycle, and it is conducting till this instant, and the moment when the current through the load, that is current across the inductor is completely exhausted, and when it is completely zero, at that instant T1 will be getting turned off. And if you see, we have provided the triggering pulse. We have provided the triggering pulse for the thyristor 2 right from this instant itself. But still, thyristor 2 is not getting turned on until T1 is completely turned off. And the moment when T1 is completely turned off, T2 should be triggered. That is the only reason we need to choose large width of the triggering pulses such that the moment when T1 is turned off, T2 can be triggered. So that is the only reason long width of triggering pulse is only suitable for full wave controller with inductive load. We never know when T1 gets turned off completely. At that instant, T2 triggering pulse need to be ready such that it will be triggered in the negative half cycle of the supply voltage. This is positive and this is negative half cycle of the supply voltage. And then during the negative half cycle of the supply voltage, now the polarities will be negative, positive, and due to which T1 is reverse bias and T2 is forward bias, and T2 now it starts conducting current through the load in the upwards direction, that is reverse to that of the first case. So that is the reason the moment when negative half cycle appeared and T2 is triggering pulse is provided, at that instant T2 starts conducting current through the load. And that too, if you see, during the positive half cycle, that is when T1 is conducting, we have got positive half cycle of the output voltage control. Whereas now, negative half cycle of the output current is controlled. And now, it has reached the instant called 2 pi. And thyristor 2 is still conducting beyond 2 pi even during the positive half cycle. It is because of the energy stored in the inductor. And because of which inductor is still conducting current through the load. And the moment it reaches 0, at that instant, if you see, again triggering pulse for the thyristor 1 is ready with a long duration of long width of the triggering pulse, such that the moment it becomes 0, we can provide the triggering pulse for thyristor 1 and it starts conducting current through the load. Thereby, continuity of the current flow will be maintained. So, which is very much required. So, this is all about the output current waveforms, where during the negative half cycle T2 has conducted and during the positive half cycle T1 has conducted. And coming to the output voltage, see here output voltage, or whatever the supply voltage which we are actually feeding, will be appeared across the load. That means here output voltage waveform will be seen as that of the input voltage in full wave controller with inductive load. That means in inductive load, we will almost lose the control over the output voltage because of the very large value of the inductor. And that is the reason, as long as supply is connected to load, here our output load voltage waveform will be exactly as that of the supply voltage waveform. So here our supply voltage waveform is like this. Output voltage waveform will be exactly following to that of the supply voltage waveform, and the cycle repeats. And now, what will be the individual current waveform for the thyristor 1? That is, as long as thyristor is conducting current through the load, we need to indicate the current waveform across the thyristor 1. That is, right from this instant, thyristor 1 started conducting, and it is conducting even beyond pi because of the presence of the energy stored in the inductor, where inductor is actually driving the current through the load. So what? It is conducting beyond pi and it is conducting as long as energy stored in the inductor is still present. And once the inductor energy stored in the inductor is completely dissipated, at that instant thyristor 1 is becoming off. So this is the current waveform across the thyristor 1, and again during the positive half cycle when the triggering pulse is provided, T1 is conducting. So this is the current across the thyristor 1. And similarly, as long as when thyristor 2 is conducting, we need to indicate the current waveform across the SCR2, that is IT2. That is when during the negative half cycle, when thyristor 2 started conducting, here we are indicating the waveform across the thyristor 2. And again the cycle repeats during the negative half cycle. This is when thyristor 2 is conducting and we need to indicate the current across the thyristor 2. As I told you, short during triggering pulses are not suitable for inductive loads. So what we make use of large width of triggering pulse or long duration triggering pulse. We never know thyristor 1 gets turned off, so that we need to be ready with the triggering pulse for the thyristor 2. Once the energy stored in the inductor is completely zero, at that instant we can trigger the thyristor 2. And in the upcoming lecture, we'll be seeing triac based AC voltage controllers. Thank you.